I will move on to the next presenter. So I'd like to invite Alexandr Tardo, researcher from CNIT, to give us insights on Port of the Future, addressing digitalization, operational efficiency and sustainability throughout a prototyping framework for Agile smart services development in Seaports. Please go ahead.
Hello and welcome to everyone. My name is Alexandr Tardo. I'm from CNIT and today I'm going to present and discuss a prototyping framework for the development of smart services and applications in maritime domain by bringing on the table the experience that we had and still have with the Port Authority of Livorno. So, as you know, the modern seaports are still dealing with the common challenges. A great part of them are related to the optimization and the improvement of the port operations, including, of course, intra-terminal operations, but not only. Another important aspect is related to the multimodal transportation and the link to the hinterland. And finally, we have typical challenges that the modern seaports are still dealing with, that is the digitalization and the sustainable development. All these challenges somehow are driven by the common priorities that come from the seaports. And it's quite interesting to notice that if we take a look at the ESPO Environmental Report 2021, a huge amount of the current priorities are focused on sustainable development. So this is something that we are going to deal during next years. So on one hand, we have all these challenges. On the other hand, we have a huge amount of modern cutting edge and disruptive technologies, if we want. So the Port of the Future is a smart port which is able to exploit such technologies in order to properly address some challenges and definitely mitigate and solve, if this is possible, some current needs from the ports. The Port of Livorno is located in Italy, in Tuscany, and it's a mid-sized historical port which deals with passengers and freights. It's a multi-purpose seaport dealing with different type of cargos. We also have a freight village for car stocking close to the port, and the port itself is located along the TNT corridor. On the other hand, we have the CNIT, which is a National Interuniversity Consortium for the Telecomunications, and we have started during past years a joint collaboration with the Port Authority of Livorno in order to speed up and support research and development activities. And one of the main advantages of this approach is just we have a real test bed that we can use during the development process in order to validate our prototypes. So our mission is based on technology transfer. We are trying to cover and consider different maritime domains, from the navigation to the intermodal logistics, to the passengers, and finally the environmental control. So what we usually do is to collect needs and requirements from the stakeholders of the port community. Then we translate them in a list of requirements, of course, after a preliminary feasibility study. And then we start the design of the prototype. So once the prototype is ready, we can test it and validate it in a real environment, of course. And during this experience, we have noticed that for the time being, there is still a lack of standard approaches, standard architectures and best practices to be used to speed up and boost research and development activities. So this is our motivation that is mainly behind the usage of this prototyping framework. So in terms of digital and physical infrastructure that we have within the Port of Livorno, we have different layers. We have an IoT layer, which includes all the devices that we are currently using for data, for monitoring purposes. We have a connectivity layer based on both wired and wireless connectivity. And then we have a software stack with different software components and tools that we are using to orchestrate the overall environment. And then all these software components and resources are deployed in a physical environment that is our laboratory located within the seaport of Livorno. And it includes all the hardware that is needed in order to be able to host such components. Regarding the prototyping framework itself, it's mainly based on service-oriented architecture. On your left, you can see a functional representation of this framework, and it allows us to manage data that we collect from the sensors, to manage and develop services or applications in a form of microservices, and to deal with authorization and authentication mechanisms for the final users or external parties. It's based on the introduction of two core components, that is data virtualization layer and enterprise service bus, in order to decouple the data layer from the business logic layer and the application layer. And we are relying on such components in order to, on one hand, to interact with different data sources that we have in Livorno, and on the other hand, to build up and develop smart applications. So mainly this prototyping framework is not going to replace existing solutions such as terminal operating systems or port community systems, but the main idea behind this prototyping framework is to provide you with tools allowing you to develop new applications by your own without the involvement of third parties. So somehow this avoids a technological lock-in, because we are not relying on proprietary solutions, and since this framework is based on standard and open source solutions, let's say that somehow we avoided this technological lock-in. So this is intended to be an open architecture that everyone, under permission, of course, is able to use in each of its component in order to develop a prototyping service. And of course, this framework supports the interoperability with proprietary solutions, as well as with legacy systems that we still have here in Livorno. And another important aspect of this prototyping framework is that it's able to support the interaction with the most common and commercial distributed ledger technologies. So in order to validate this framework, we have implemented just a few services as examples. It's not about the complexity of the services itself, but instead the main aim is to demonstrate that we can easily develop and quickly develop some services based on data sources and data lake that we have in Livorno. So you can see here typical applications that we have developed. Of course, you don't need to invest a lot of effort in order to build up an application which is able to compute somehow the ship state time for the instance. But in order to demonstrate the scalability of the proposed framework, we were able to easily develop such service based, for instance, on available data sources, and that's let's say somehow the same for other applications. So in order to be able to use physical resources, we rely on industrial partnership with different international partners, so which somehow provides us with different resources, mainly with telecommunication equipment and connectivity resources. So we have a partnership with industrial partners such as Ericsson or TIM, which is the main mobile operator in Italy, and we have industrial partnership with the institutions and so on. And during last period, we have started another collaboration with BMT Group in order to facilitate let's say, the transition to the sustainable and productive operations in ASEAN region. So we are going to consider, and we would like to put our focus on ports from Asia, because we are aware that there are still different challenges that specific ports from Asia are still dealing with. And since BMT has a lot of knowledge in that sector, in this specific field, we do believe that this joint collaboration is going to be productive, because on our hand, we can provide some tools in order to speed up and boost the prototype implementation. And then we can rely on BMT expertise in order to to refine the product, as well as to perform some re-engineering operations. And the idea here is to come up during next future with some innovative services by considering two main domains, that is the Internet of Ships and smart ports. So we are interested in introducing new services, and in this case they are going to be innovative services in order to properly address some issues such as the dynamic congestion, so the congestion at the seaport gates, the predictive maintenance, so all those operations based maybe on artificial intelligence or machine learning algorithms, in order to be able to foresee some operations related to the maintenance. Then we are also interested in the monitoring of the yard assets and equipment, and other aspects that are related mainly to the ship itself, such as the automatic berthing, real-time vessel route planning and optimization, or real-time cargo tracking and monitoring. So that's all from my side. Thank you for your attention.
Thank you, Alexandr. The floor is now open to questions. No questions for Alexandr? Okay, in that case, I guess we will proceed.